Today we're going to be looking at finding the area of composite figures. So a composite figure is a figure that's composed of a variety of two-dimensional shapes. Composite figures are often split into their component shapes to calculate the area. So here are a few examples. So this entire pink shape is made of 3 rectangles. Then you have this blue shape that's made of 2 rectangles and 2 triangles. Here's a rectangle and a semicircle, and so on. So these are all composite shapes. When we're trying to find the area of composite shapes, please make sure that you are familiar with this formula sheet. This is the exact formula sheet that you are going to have on the SOL. So it's really good to get familiar with this. We're going to be using these 4 along the top and then these first 2 in the second row. So whenever we're finding the area, the first thing we need to do is subdivide or cut the figure into smaller shapes. Then we have to find the correct formulas, so calculate the area of each individual piece. Then we add them all together, and remember that area is always going to be units squared. So here is the first example. So this looks like an ice cream cone, and I'm just going to go through my steps. So my first step is to subdivide or cut the figure into simple shapes. So this shape, I can cut it straight across here, and we'll have a semicircle and an upside down triangle. Okay? So once I've got that cut, I kept the measurements. All right, now something with this triangle, half of it over here was labeled as 5. So I went ahead and put a 5 on the other half so that I can see the whole length of the base of this triangle. The reason I needed that is because when I go to find the formulas, I see that the formula for my triangle was 1/2 base height. So I needed the whole base. 5 was only half of it, so I needed both of these to represent the base. For the semicircle, so the area of a circle is pi r squared, and I know that from looking at my formula sheet, a equals pi r squared, but this is only half of a circle. So I actually had to divide that area by 2. Now I'm going to take the numbers, the values that were given to me, and plug them in. Now I'm actually just going to type this into Desmos. So I just looked at what variable I needed, and I typed that variable in, r equals 5. I typed in the formula, so 3.14 r squared divided by 2, and it just gave me the answer of 39.25. So you guys just seriously just type it into the calculator. Same thing with the triangle. I'm going to type in my formula and type in the values. So please notice that the base of this triangle is not 5. The base altogether measured 10. So my base was 10, my height was 8, plugging into my formula, Desmos told me was 40. Okay, so I just typed this in exactly how it looks into Desmos, and it tells me my answer is 40. Now that we've got our individual areas, we add them all up to get the total area. So 39.25 plus 40 gives me a final answer of 79.25 inches squared. And that's how you do this first one. Give you guys a minute to look at it. Okay, let's look at a second example. For example 2, we have this sort of looks like a rocket ship or something, but I'm going to just cut it straight across so that I'm left with the triangle on the top, rectangle in the middle, and a trapezoid on the bottom. So I just cut all of those, and I've left the measurements the way that they were in my original shape. Okay? The only one that I had to add was right here. So the base of my triangle doesn't have a number, doesn't have a measurement, But I know that because this is a rectangle here in the middle, because this is a rectangle, if this is 15, this also had to be 15. So that's how I knew that the bottom of my triangle was going to also be 15. Now I'm going to look, my first thing to do after I subdivide the shape is to figure out the appropriate formulas for this triangle. So I'm going to look on my formula sheet. Triangle area is 1/2 base height. My rectangle, so I can look on my formula sheet. Here's my rectangle. We're talking about the area, guys. We are not talking about perimeter. We're talking about area. So area equals length times width. And then for the trapezoid, I can look on my formula sheet. Here is my trapezoid. So I get 1/2 height times the sum of base 1 and base 2. Okay? Now I need to figure out, well, what are my variables? What do they equal so that I can plug it into this formula into Desmos? So I'm just going to type this formula exactly how it is. Just type it into Desmos and then plug in some values. So I'm seriously just going to type this straight into Desmos just like the way it is and plug in the values. So the base of my triangle was 15. The height was 9. So I just type this into Desmos, and it's going to show me that that means the area is equal to 67.5. So I'm just typing it into the calculator. Same thing for this one. I'm going to type my formula in like this. I just type it in the calculator. My length was 15. The width was 4. So I type all that in. And Desmos tells me that this has an area of 60. Okay, this is just like when we did variable substitution way back in like unit 1 or something in pre-algebra. So you should be familiar with plugging numbers into the calculator for variable substitution. Now this one is a little bit different, the way that you type this in. So I'm going to show this one to you in Desmos. Open it up, and I am using the scientific calculator. Okay. When I go to type in my area of a trapezoid formula, so I'm going to do A equals 1/2 times height times base 1. Now to get that little 1 down there, you're going to do shift and then press the minus sign on your keyboard, and it's going to go down there and make a little small number. Okay, then I'm going to press the over key, or you can click there to make it not be small anymore, plus B2. So same thing, I'm going to use shift and then press the minus sign, and it makes a small number down there for base 2. And same thing, I'm going to click so that my key is bigger, it's not small anymore, and close off my parentheses. Okay, so that's how I'm going to type that into the calculator. The height is this dotted line that's separating the bases. And I knew that by looking at my formula sheet. So if I look at the formula sheet, it labels things for me. It shows me that that dotted line between the bases is the height. The parallel sides are my bases. So I'm going to type in, it has a height of 4. So I'm literally just going to do H equals 4. Okay, then base 1 is, let's look. So base 1 is supposed to be the top. So the top here, 15. And then base 2 was 18. Because that's what's across the bottom. Okay, so I just typed all this in, and look. My area is 66. So I'm just typing it into the calculator, exactly what the formula says, and it's giving me my answer. 66. To get the total area, so my triangle piece was 67.5, the rectangle piece was 60, the trapezoid was 66. So guys, all three of these shapes fit together to make one big shape. So to get the area, I need to take all of the areas and add it together to get one big area, okay? So the total area, I'm gonna just add these three values up and I get 193.5 centimeters squared. It is gonna be squared because we are talking about area, okay? I'm gonna give you just a minute to look at this one. Okay. Last example, example 3. This one's a funny looking shape. I don't even know what to describe it as, but I do see that if I were to cut across here and subdivide this shape, I have a triangle in the top, a rectangle, and technically this is a square, but it's a rectangle, and then a parallelogram across the bottom. Okay. Now I know some people might look at this and say, "Oh, but Miss Mullins, these are two triangles," right? I mean, yeah, you're not wrong, but why make things more complicated than they need to be? Okay. This is just one triangle sitting on top of one square or rectangle, and then you have your parallelogram at the bottom. Okay. So I'm going to look at my formula sheet and get my formulas. For a triangle, the area of a triangle is 1/2 times base times height. The area of a square is technically side squared, and I'm going to show you guys this. So a square is technically side squared. I will be honest with you, I do not ever use the square formulas because I think they're very specific and a little bit too narrow. I always use a rectangle because it's the same thing. So I use the rectangle formula, length times width, and then my parallelogram. So here's a parallelogram. Area equals base times height. Okay. I knew this was a parallelogram because when I look at the opposite sides, I noticed that they're parallel. They have the same slope with each other. So that's how I knew this was a parallelogram. Okay. So that's my first step, is to subdivide and then come up with the formulas by looking at my formula sheet. Now that I've done that, I can start plugging this into Desmos. Just like I showed you with that trapezoid a second ago when I did the one here in Desmos, you just type the formula in. You just take the formula and type it in, and then you need to see what the variables equal. So for this one, I need to know base and height. The base is the bottom of the triangle that the height sets on. So here's the height, here's the base. So I just plug that in, plugged in my formula, what base equaled, what height equaled, and it told me 14. Just plugged it in the calculator. Same thing with this one, A equals LW. Now because this is a square, the length and the width are both 7. So it's just 7 and 7, which gives me 49. So I'm just plugging into the calculator and letting the calculator do all of the work for me. Same thing here. I'm going to plug in A equals BH into the calculator. We can do this one in here to show you. So A equals base times height. So I need to know what is the base and what is the height. Well, looking at my shape, the base is this distance along here, and then the height is what separates those bases. It's perpendicular to the base. So it has a base of 7, a height of 3. So base of 7, height of 3. And look, it tells me the answer up here that this has an area of 21. Okay? So that's all the individual areas. Just like how this original figure over here was composed or made of 3 smaller figures, the area of this is going to be made or composed of 3 areas put together. So to get the total area, I have to take these values that I got, 14, 49, and 21 and add them together to get the total area of 84 yards squared or square yards. Okay, so I'm going to pause a minute and let you look at this one. Okay, well, that's it for this class kick. Make sure that you understand these steps that you're supposed to do, and make sure that you are familiar with this formula sheet.